On to Babylonian numerals. These are the fun ones, aren't they? So you're going to do this in 2 stages. So to remind you how you do this, remember to think, first of all, we're going to deal with the symbols. So here you have, that's the easy part. So at the very least, you could do this, 21, 11, and 2. So I'm just taking this stuff and translating the various symbols into groupings. But then you have to think in terms of time. Remember that our time comes from the Babylonians. And so this is 21 hours. So that's 21 times 60 squared, or 3,600. There are 3,600 seconds in an hour. And then you have 11 times 60, because there's 60 seconds in a minute. And then the 2 leftovers at the end. I'm actually going to just use my calculator here. So that's 21 times 3,600. That's 60 times 60, by the way. 11 times 60. And then the 2 leftovers. Why did it not add up? Hold on a minute. Let's try again. 3,600. I suppose I could do this here like this. 75,600 plus 660 plus 2, and that is 76,262. All right, this next one. Do the translation first, like this, 11:3. So this is like 11 minutes and 3 seconds. How many seconds is this? So it's 11 times 60 plus 3 leftovers. So that will be 660 plus 3 leftovers, which is 663. All right, doing it the other way is much more difficult. So what I'd suggest here is, so this is, think of this as seconds, is 2 minutes and 1 second. So that's literally what 121 seconds is. But if you didn't know that, you could do it this way. 121 divided by 60 is equal to 2.0, hold on a minute, 0.1667. So this is where the 2 minutes comes from. And then to figure out the number of seconds, you could say 2 minutes. So 2 times 60 is 120. And 121 minus 120 is 1. And that's where the 1 second comes from. Well, once you have it like that, it's easy to use the symbols up here to come up with your, there's going to be 2 minutes. So I'll just do 2 of these things. And then over here, leave a little gap so that we know it's a different place value. So 2 minutes and 1 second. Looks like that. Box it up. All right, let's see if we can work this one out. This one's a little bit harder. So this is, once again, think of it as seconds. And we want to be able to write this in terms of hours, minutes, and seconds. So here's how we're going to do this. There are 3,600 seconds in 1 hour. So my first move, and we might have done it a little bit differently in class. There's 2 different ways of doing this. But I'm going to do it this way because that's the way I'm feeling today. If you want to do it the other way, bug me about it later. So this gives me 30.864166, whatever. So that's the number. So this here tells me that that's 30 hours. But then I need to figure out how many minutes there are. So what I'm going to do is I'm going to do this. 30 hours is equal to 30 times 3,600. That's 108,000 seconds. So 30 hours is 108,000 seconds. And I'm interested in this number of seconds. So I'll do this. and I get 3,111. So now I'll take that 3,111, divide that by 60, and I got 51.85. And the 51, that's going to go up here as 51 minutes. Now I just have to figure out the number of seconds. And so I'm going to do this thing again that I did up top. 51 minutes is equal to, let's see, 51 times 60, 3,060 seconds. And I've run out of room, so I'll just draw an arrow here. 3111 minus 3060. 3111 is 51. So that's 51 seconds. So that goes up there. 51 seconds. Now I just have to translate this to Babylonian, which is a little bit of a pain, but we're going to have 3 of these. Let's see, 1, 2, 3. So there's the number of hours. And then we have 5 of them. 1, 2, 3. I'm just going to draw them like this. I know there's different ways to draw it, but we'll just keep it simple. And then 1. So that's the number of minutes. And then because I can do it on here, I can just copy this. And there, because that's 51 as well. Ooh, that's off the page. Let me move this back. Okay, we have to move everything. That's better. Let me box this up. And this thing goes down here. There. All right, what else do we have on this page? Looks like some Euler paths. So which of these have Euler circuits, which have Euler paths? So let's remind you that a path, let's start with the circuit. Let's do this. So number of odd vertices, and if there is none, then you get a path and a circuit. If you have exactly 2, then you just have a path, but no circuit. And if there are more than 2, then neither. So there's the rule, or the set of rules. Okay, I'll just move this down a bit so we can write. So what I'm going to do is I'm going to highlight or circle the odd vertices. So anything that has an odd number, in fact, here, I'll write them down here. This is 2, this is 4, 2, this is 2, this is 3, this is 3. So this here is not a vertex, not a vertex. Just to emphasize, so here are the oddballs, and so there are two odd vertices. So there's an Euler path, but not a circuit. All right, let's do the next one. Let's see, this is 4, 2, 4, 2, 2. And so this one has no odd vertices. So you have an Euler circuit and an Euler path. All right, what in the world is this crazy thing doing? Well, let's find out. So we have a 1 here. This is 2, 2, 3, and 1. So let's circle the odds. Those are odd, and these are odd. So this one is whoops, this one's more than 2 odds. So this one has neither. Maybe I'll just box these. There we go. All right, you know what? This last one looks exactly like the second one, just rotated. So this one has no odd vertices as well, and so it has an Euler path and an Euler circuit. It's the same. Hopefully you can see that. So I'm just going to duplicate this. It's the exact same graph, just it's been rotated a little bit. So there it is.